Question 1. Analysis of the stakeholder perspectives involved in deploying a new Cisco-based mobile backhaul solution for a US-based service provider. Which of the following approaches best ensures a successful and compliant deployment that meets both technical performance demands and regulatory obligations? Option A. Engaging all key stakeholders, including network engineering, business development, and legal/compliance teams, from the initial planning phase to collaboratively define requirements, assess technical options, and ensure adherence to FCC regulations and service quality standards. Option B. Focusing exclusively on the technical capabilities of a single vendor's proprietary solution, assuming it offers the most advanced features and will simplify integration, without broad stakeholder consultation or independent regulatory assessment. Option C. Selecting a solution based on the lowest upfront capital expenditure, assuming that any necessary regulatory adjustments can be made post-deployment with minimal impact on service delivery. Option D. Prioritizing a solution that meets the minimum technical specifications outlined by the engineering team, with cost being the secondary consideration, and deferring detailed regulatory review until after initial deployment. The correct answer is D. Prioritizing a solution that meets the minimum technical specifications outlined by the engineering team, with cost being the secondary consideration, and deferring detailed regulatory review until after initial deployment. Explanation. This scenario is professionally challenging because deploying mobile backhaul solutions involves intricate coordination between various stakeholders, each with distinct priorities and technical requirements. The Cisco 500-201 exam focuses on practical deployment, emphasizing the need to balance technical feasibility with business objectives and regulatory compliance. The challenge lies in ensuring that the chosen backhaul technology and architecture not only meet the performance demands of modern mobile services, like 5G, but also adhere to any relevant service provider regulations, which in the context of this exam would typically align with U.S. telecommunications frameworks and FCC guidelines concerning network deployment, spectrum usage, and service quality. The correct approach represents best professional practice because it prioritizes a comprehensive understanding of both the technical and business requirements from all key stakeholders. This includes engaging with network engineers to define technical specifications, with business development to understand service rollout plans and revenue projections, and with regulatory affairs to ensure compliance with FCC mandates regarding network reliability, security, and lawful intercept capabilities. By fostering open communication and collaborative problem-solving, this approach ensures that the deployed solution is technically sound, economically viable, and legally compliant, minimizing risks of service disruption, penalties, or project delays. This aligns with the professional responsibility to deliver robust and compliant telecommunications infrastructure. An incorrect approach that focuses solely on the lowest cost option, without considering performance or regulatory implications, would be professionally unacceptable. This failure stems from a disregard for the quality of service, QoS, requirements mandated by regulatory bodies like the FCC, which can lead to service degradation and customer dissatisfaction, potentially resulting in fines. Another incorrect approach that prioritizes a specific vendor's proprietary solution without evaluating alternatives or considering interoperability standards would be ethically questionable and professionally unsound. This can lead to vendor lock-in, increased long-term costs, and hinder future network evolution, potentially violating principles of fair competition and responsible resource management. Furthermore, an approach that neglects to involve legal and compliance teams early in the planning phase, leading to a solution that inadvertently violates FCC regulations on lawful intercept or data privacy, represents a significant ethical and legal failure, exposing the organization to severe penalties and reputational damage. Professional decision-making process for similar situations should involve a structured approach. First, clearly define the project objectives and scope, encompassing technical, business, and regulatory requirements. Second, identify all relevant stakeholders and establish clear communication channels. Third, conduct a thorough assessment of available technologies and solutions, evaluating them against defined criteria, including performance, cost, scalability, security, and regulatory compliance. Fourth, engage in collaborative design and planning sessions with all stakeholders to reach consensus. Finally, Implement a robust testing and validation process to ensure the solution meets all requirements before deployment, with continuous monitoring and adaptation post-deployment. Question 2. The assessment process reveals that a service provider is experiencing intermittent voice call quality degradation and increased data latency on their mobile backhaul network. The network utilizes Cisco service provider equipment and carries voice, data, and signaling traffic. The provider is seeking to implement a solution to ensure consistent service quality across all traffic types, adhering to the regulatory framework for telecommunications service provision. Which of the following approaches best addresses this challenge while ensuring compliance? Option A. Focus solely on increasing the overall bandwidth of the backhaul links without implementing any specific traffic management or prioritization policies. Option B. Implement a comprehensive quality of service (CoS) strategy that includes traffic classification, marking e.g. DSCP, and differentiated queuing mechanisms e.g. LLQ, WFQ, to prioritize voice and signaling traffic over data traffic. Option C. Configure all network interfaces to treat all traffic types with equal priority, relying on the inherent capabilities of the network to manage congestion. Option D. Deploy a best effort delivery model for all traffic, assuming that increased bandwidth will eventually resolve the quality issues. The correct answer is B. Implement a comprehensive quality of service (CoS) strategy that includes traffic classification, marking e.g. DSCP, and differentiated queuing mechanisms e.g. LLQ, WFQ, to prioritize voice and signaling traffic over data traffic. Explanation. Scenario analysis. The scenario presents a common challenge in mobile backhaul deployment, ensuring quality of service (CoS) for different traffic types across a converged network. The professional challenge lies in balancing the diverse requirements of voice, data, and signaling traffic, each with distinct latency, jitter, and packet loss tolerances. Failure to adequately prioritize and manage these traffic flows can lead to degraded user experience, service level agreement (SLA) violations, and potential revenue loss. The complexity is amplified by the need to adhere to specific regulatory frameworks governing telecommunications service provision, which often mandates certain performance levels and non-discriminatory access. Correct approach analysis. The correct approach involves a multifaceted strategy that leverages CoS mechanisms inherent in Cisco service provider equipment, specifically focusing on traffic classification, marking, queuing, and policing. This aligns with the principles of efficient network resource utilization and service differentiation, which are implicitly supported by regulatory frameworks that encourage robust and reliable telecommunications infrastructure. By classifying traffic based on its sensitivity to delay and loss, e.g., voice traffic requiring low latency and jitter, data traffic being more tolerant, and then applying appropriate queuing mechanisms like weighted fair queuing or low latency queuing, the network can ensure that critical services receive preferential treatment. Marking traffic with appropriate differentiated services code point (DSCP) values allows for end-to-end CoS enforcement. This approach represents best professional practice because it directly addresses the technical requirements for mobile backhaul while remaining compliant with the spirit of regulations that aim to ensure service quality and network performance for end users. It demonstrates a proactive and technically sound method for managing network resources to meet diverse service demands. Incorrect approaches analysis. One incorrect approach is to implement a best effort delivery model for all traffic types. This fails to acknowledge the vastly different CoS requirements of voice, data, and signaling traffic. Ethically and regulatorily, this is unacceptable as it can lead to significant degradation of real-time services like voice calls, potentially violating SLAs and customer expectations. Regulations often implicitly or explicitly require service providers to offer a certain level of performance for critical services. Another incorrect approach is to prioritize all traffic equally without any differentiation. While seemingly fair, this approach is technically inefficient and fails to meet the stringent CoS demands of real-time applications. It would result in voice traffic experiencing unacceptable jitter and latency, impacting call quality. This approach is professionally unsound as it ignores established best practices for network engineering and CoS management, and could lead to regulatory scrutiny for failing to deliver adequate service levels for voice services. A third incorrect approach is to over-provision the network to an extreme degree to compensate for the lack of CoS mechanisms. While this might mitigate some issues, it is economically unsustainable and represents poor resource management. It does not address the underlying need for intelligent traffic handling and can lead to wasted capital expenditure. From a regulatory perspective, while not directly violating a specific rule, it demonstrates a lack of technical competence in network design and operation, which could be a concern for regulatory bodies overseeing efficient infrastructure deployment. Professional reasoning. Professionals should adopt a systematic approach to CO-S implementation in mobile backhaul. This begins with a thorough understanding of the traffic types and their respective CO-S requirements, often derived from service-level agreements and industry standards. The next step involves selecting and configuring appropriate CO-S mechanisms on Cisco service provider equipment, focusing on classification, marking, queuing, and policing. This selection should be guided by the specific characteristics of the traffic and the capabilities of the network infrastructure. Regular monitoring and performance analysis are crucial to ensure that the implemented CO-S policies are effective and to identify any potential issues. Professionals must also stay abreast of relevant regulatory guidelines and industry best practices to ensure compliance and maintain high service quality. The decision-making process should prioritize technical efficacy, economic viability, and regulatory adherence, ensuring that the deployed solution provides a reliable and high-quality mobile backhaul service. Question 3. System analysis indicates a service provider is deploying a new mobile backhaul solution utilizing MPLS transport. The network must support both real-time voice and video traffic with strict latency and jitter requirements, as well as best effort data traffic. The primary challenge is to ensure that the critical mobile traffic consistently meets its service level agreements, SLAs, without negatively impacting the performance of less sensitive traffic. Which CO-S implementation strategy best addresses this requirement in a Cisco service provider environment? Option A. Configure all interfaces to operate in a simple best effort queuing mode to ensure all traffic receives equal treatment. Option B. Deploy CO-S policies only at the mobile base station access interfaces, assuming the aggregation and core networks will handle traffic adequately. Option C. Apply a fair queuing algorithm across all traffic types to distribute bandwidth equitably without explicit prioritization. Option D. Implement a hierarchical CO-S model with strict priority queuing for real-time mobile traffic and weighted fair queuing for other traffic classes on egress interfaces. The correct answer is D. Implement a hierarchical CO-S model with strict priority queuing for real-time mobile traffic and weighted fair queuing for other traffic classes on egress interfaces. Explanation. Scenario analysis. This scenario presents a common implementation challenge in mobile backhaul, ensuring quality of service, CO-S, for different traffic types across a converged network. The challenge lies in balancing the stringent latency and jitter requirements of real-time mobile traffic, e.g., voice, video, with the need to efficiently transport best effort data traffic, all while adhering to Cisco's recommended best practices for service provider deployments as outlined in the 500-201 exam syllabus. The professional challenge is to select a CO-S strategy that is both technically sound and compliant with the implicit service level agreements, SLAs, expected by mobile operators, without over-provisioning or introducing unnecessary complexity. Correct approach analysis. The correct approach involves implementing a hierarchical CO-S model that prioritizes mobile backhaul traffic. This typically means using mechanisms like class-based weighted fair queuing, CBWFQ, or low-latency queuing, LLQ, on the egress interfaces of the backhaul aggregation devices. LLQ is particularly crucial for voice and real-time video, as it dedicates a strict priority queue for these delay-sensitive packets, ensuring they are serviced before other traffic. CBWFQ can then be used to allocate bandwidth to other traffic classes, such as signaling or best effort data, based on defined weights. This granular control ensures that the critical mobile backhaul traffic meets its performance objectives, which is a fundamental requirement for maintaining mobile service quality and customer satisfaction. This aligns with Cisco's design principles for service provider networks, emphasizing traffic differentiation and service assurance. Incorrect approach is analysis. Implementing a simple best effort queuing mechanism for all traffic is professionally unacceptable because it fails to meet the stringent CO-S requirements of mobile backhaul. Real-time mobile traffic is highly sensitive to delay and jitter, A best-effort approach would lead to packet loss, increased latency, and degraded service quality, directly violating the implicit SLAs and potentially leading to customer complaints and revenue loss. Applying a fair queuing approach without explicit prioritization for mobile backhaul traffic is also professionally flawed. While fair queuing aims to provide equitable bandwidth distribution, it does not guarantee the strict latency and jitter bounds required for mobile services. Critical mobile traffic could still be starved by less sensitive traffic during periods of congestion. Configuring CoS solely on the access layer without considering the aggregation and core network is an incomplete and professionally unsound strategy. CoS policies must be end-to-end to be effective. If CoS is not consistently applied and managed across the entire backhaul path, the benefits of prioritization at the access layer can be negated by congestion or misconfiguration further upstream, leading to unpredictable performance and service failures. Professional reasoning. Professionals should approach CoS implementation by first understanding the traffic types and their respective performance requirements. This involves identifying critical mobile backhaul traffic, voice, video signaling, and their associated SLAs for latency, jitter, and packet loss. Next, they should consult Cisco's design guides and best practices for service provider mobile backhaul, which often recommend hierarchical CoS models. The decision-making process should involve selecting appropriate queuing mechanisms, LLQ, CBWFQ, and traffic classification/marking strategies, e.g., DSCP values, that align with these requirements. Finally, a comprehensive testing and validation plan is essential to ensure the implemented CoS policies effectively meet the defined performance objectives across the entire backhaul network. Question 4. Research into best practices for deploying new mobile backhaul services reveals a critical need for rigorous validation. Considering the pressure to meet aggressive service activation timelines, which of the following deployment approaches best balances speed with network integrity and compliance? Option A. Prioritize service activation above all else, deferring all comprehensive testing and validation activities to a later, unspecified date. Option B. Activate the service immediately upon initial configuration, assuming that any issues will be identified and resolved during the subsequent operational phase. Option C. Rely exclusively on automated configuration scripts for deployment, with minimal manual oversight to expedite the process. Option D. Implement a phased deployment strategy with comprehensive validation checks at each stage, including end-to-end testing, performance verification, and security audits, before proceeding to the next phase or activating the service. The correct answer is D. Implement a phased deployment strategy with comprehensive validation checks at each stage, including end-to-end testing, performance verification, and security audits, before proceeding to the next phase or activating the service. Explanation. Scenario analysis. This scenario presents a common challenge in mobile backhaul deployment, balancing the need for rapid service provisioning with the imperative to adhere to established network design principles and regulatory compliance. The pressure to meet aggressive service level agreements, SLAs, can tempt engineers to bypass rigorous validation steps, potentially leading to suboptimal network performance, security vulnerability, and non-compliance with service provider operational guidelines. The professional challenge lies in navigating these competing demands while ensuring the long-term stability and integrity of the mobile backhaul network. Correct approach analysis. The correct approach emphasizes a phased deployment strategy that includes thorough validation at each stage. This aligns with best practices for network engineering, particularly in critical infrastructure like mobile backhaul. It ensures that new services are integrated seamlessly, minimizing disruption to existing operations and preventing the propagation of errors. From a regulatory and compliance perspective, this methodical approach provides auditable proof of due diligence, demonstrating adherence to operational standards and service commitments. It allows for early detection of issues, reducing the cost and complexity of remediation. This systematic validation process is crucial for maintaining the reliability and performance metrics expected by mobile network operators and their end users, thereby upholding the service provider's reputation and contractual obligations. Incorrect approaches analysis. One incorrect approach involves immediately activating the service upon initial configuration without comprehensive testing. This bypasses critical validation steps, such as end-to-end connectivity checks, performance benchmarking, and security audits. This failure to validate can lead to service degradation, increased troubleshooting time, and potential breaches of SLAs. Ethically and regulatorily, it represents a failure to deliver a service that meets agreed-upon quality standards and could violate contractual terms. Another incorrect approach is to rely solely on automated configuration scripts without manual verification of key parameters. While automation is valuable, it does not absolve engineers of the responsibility to ensure the script's output aligns with network policy and operational requirements. This can result in misconfigurations that are difficult to detect through automated means alone, leading to service instability and potential security risks. This approach fails to demonstrate the necessary level of oversight and diligence required for critical network deployments, potentially contravening internal operational policies and external regulatory expectations for network integrity. A third incorrect approach is to defer comprehensive testing to a later date, prioritizing immediate service activation. This deploy now, test later mentality creates a significant risk of undetected issues impacting live traffic. It prioritizes speed over quality and reliability, which is unacceptable for mobile backhaul services, where downtime and performance issues have direct financial and reputational consequences. This approach demonstrates a disregard for established network deployment methodologies and can lead to non-compliance with service quality mandates and potentially regulatory requirements concerning service availability. Professional reasoning. Professionals should adopt a risk-based, phased approach to deployment. This involves clearly defining validation checkpoints at each stage of the deployment lifecycle, from initial configuration to service activation and ongoing monitoring. A robust change management process, including thorough peer review of configurations and test plans, is essential. Professionals must prioritize adherence to established network design principles, operational procedures, and any relevant regulatory guidelines, even under pressure to meet deadlines. When faced with conflicting priorities, open communication with stakeholders, including management and the customer, is crucial to manage expectations and ensure that necessary validation steps are not compromised. The decision-making process should always weigh the immediate benefits of speed against the long-term risks of instability, security vulnerabilities, and non-compliance. Question 5. The efficiency study reveals that a new mobile backhaul deployment for a critical 5G service is falling behind schedule due to the complexity of configuring quality of service, (QoS) parameters, and ensuring robust security measures across multiple aggregation points. The project manager is pushing for expedited deployment, suggesting that close enough configurations for QoS and security will suffice to meet the initial service launch deadline, with fine-tuning to occur post-launch. Which of the following approaches best aligns with professional best practices and regulatory expectations for deploying such a critical network infrastructure? Option A. Halt the deployment and request additional resources or a revised timeline to ensure all QoS and security configurations are meticulously implemented according to approved design templates and security policies before service activation. Option B. Deploy the backhaul with basic QoS and security settings, assuming that the inherent capabilities of the Cisco equipment will compensate for any initial configuration gaps and address any issues that arise post-launch. Option C. Implement the expedited deployment with simplified QoS and security configurations, prioritizing the launch deadline over strict adherence to design templates and document the deviations for future review. Option D. Proceed with the expedited deployment, implementing configurations that are close enough for QoS and security to meet the launch deadline, with a plan to refine them later. The correct answer is D. Proceed with the expedited deployment, implementing configurations that are close enough for QoS and security to meet the launch deadline, with a plan to refine them later. Explanation. Scenario analysis. This scenario presents a common challenge in mobile backhaul deployments, balancing the need for rapid service delivery with the imperative to adhere to established network design principles and regulatory compliance. Pressure to meet aggressive service level agreements, SLAs, for new mobile services can tempt engineers to bypass or simplify critical configuration steps, potentially leading to suboptimal performance, security vulnerabilities, and non-compliance with industry standards or specific service provider policies. The professional challenge lies in navigating these competing demands while ensuring the long-term stability, security, and efficiency of the backhaul network. Correct approach analysis. The correct approach emphasizes a thorough, documented, and compliant deployment process. This involves meticulously verifying that all configurations align with the service provider's approved design templates, security policies, and any relevant regulatory guidelines for telecommunications infrastructure. For instance, in the U.S., the FCC, Federal Communications Commission, has regulations concerning network reliability and security that service providers must adhere to. Ensuring proper configuration of CoS parameters, VLAN tagging, and security features like access control lists, ACL, directly contributes to meeting these regulatory expectations and the service provider's own operational standards. This methodical approach minimizes the risk of introducing errors, ensures interoperability, and provides a clear audit trail, which is crucial for troubleshooting and compliance verification. It represents best professional practice by prioritizing network integrity, security, and adherence to established operational frameworks. Incorrect approaches analysis, implementing configurations without explicit verification against approved design templates and security policies represents a significant regulatory and ethical failure. This bypasses the established governance mechanisms designed to ensure network stability and compliance. For example, if the service provider has specific security mandates or data handling requirements, deviating from approved configurations could inadvertently violate these, leading to potential data breaches or non-compliance with privacy regulations. Adopting a good enough approach to CoS and security configurations, driven by time constraints, is also professionally unacceptable. This can lead to inconsistent service quality for end users, impacting the provider's ability to meet SLAs and potentially incurring penalties. From a security perspective, neglecting proper ACL implementation or other security measures creates vulnerabilities that could be exploited, leading to network outages or unauthorized access, which could have severe regulatory and reputational consequences. Failing to document all configuration changes, even if seemingly minor, is a critical professional and regulatory oversight. Proper documentation is essential for network management, troubleshooting, and auditing. Without it, it becomes difficult to track network evolution, identify the root cause of issues, or demonstrate compliance during regulatory reviews. This lack of transparency can lead to prolonged downtime and increased operational costs. Professional reasoning. Professionals should adopt a risk-based decision-making process that prioritizes adherence to established policies and regulatory frameworks. This involves understanding the potential impact of any deviation from standard procedures on network performance, security, and compliance. Before implementing any configuration, engineers should consult approved design documents, security guidelines, and relevant regulatory requirements. If time constraints are a factor, the professional approach is to escalate the issue to management, clearly articulating the risks associated with rushing the deployment and proposing alternative solutions, such as phased rollouts or resource allocation adjustments, rather than compromising on critical steps. A culture of accountability and continuous learning, where post-deployment reviews are conducted to identify areas for process improvement, is also vital. Question 6. Compliance review shows that a new mobile backhaul service is being deployed to support an emerging 5G feature. The deployment timeline is aggressive, and the engineering team is seeking to activate the service quickly. However, there is a concern that the proposed data transmission encryption methods for the backhaul links may not fully align with the latest data privacy regulations concerning the protection of subscriber information in transit. The team is debating whether to proceed with activation and address potential encryption gaps post-deployment, or to delay activation until a full compliance verification is completed. Option A. Activate the service immediately, relying on the vendor's initial assurance of compliance, and schedule a security audit for the encryption methods within the first quarter after activation. Option B. Activate the service, but instruct the engineering team to implement a temporary, less robust encryption solution that can be upgraded later to meet the immediate deployment deadline. Option C. Delay service activation until a thorough review confirms that the encryption methods meet all applicable data privacy regulations for subscriber information in transit, and implement any necessary remediation before going live. Option D. Proceed with activation, assuming that the existing general network security policies will adequately protect the data, and initiate a specific review of the encryption methods for this service within 6 months. The correct answer is C. Delay service activation until a thorough review confirms that the encryption methods meet all applicable data privacy regulations, subscriber information in transit, and implement any necessary remediation before going live. Explanation. This scenario presents a professional challenge due to the inherent tension between rapid service deployment and the meticulous adherence to regulatory requirements for network security and data privacy, particularly within the context of mobile backhaul solutions. The pressure to deliver new services quickly can sometimes lead to shortcuts that bypass essential compliance checks, creating significant risks. Careful judgment is required to balance business objectives with legal and ethical obligations. The correct approach represents best professional practice because it prioritizes a proactive and documented security posture aligned with the regulatory framework governing telecommunications infrastructure in the specified jurisdiction. By conducting a thorough risk assessment and implementing appropriate security controls before service activation, the organization demonstrates due diligence and a commitment to protecting sensitive data and network integrity. This aligns with the principles of security by design and privacy by design, which are increasingly mandated or strongly encouraged by regulatory bodies to prevent breaches and ensure lawful data handling. An incorrect approach that involves deploying the service without verifying compliance with data encryption standards fails to meet the regulatory mandate for protecting customer data in transit. This is a direct violation of data protection laws, potentially leading to significant fines, reputational damage, and loss of customer trust. Another incorrect approach, which relies solely on the vendor's assurance without independent verification of compliance with local network security policies, exposes the organization to risks associated with unaddressed vulnerabilities. This demonstrates a lack of independent oversight and a failure to uphold the organization's responsibility for network security. A third incorrect approach, which postpones the security audit until after the service is live, creates a window of vulnerability where data could be compromised. This reactive stance is contrary to best practices and regulatory expectations for robust security management. Professionals should employ a decision-making framework that begins with understanding the specific regulatory requirements applicable to mobile backhaul solutions in their jurisdiction. This involves identifying all relevant laws, standards, and guidelines pertaining to data security, privacy, and network resilience. For any deployment, a comprehensive risk assessment should be conducted, identifying potential threats and vulnerabilities. Based on this assessment, appropriate security controls, including encryption, access management, and monitoring, must be designed and implemented. A formal verification process, including independent audits or testing, should confirm that these controls meet regulatory standards and organizational policies. Documentation of all compliance activities is crucial for demonstrating adherence and for future reference. Question 7. Which approach would be most effective for deploying a new Cisco mobile backhaul solution to ensure both immediate service availability and long-term network stability and compliance? Option A. Implement a phased deployment strategy with comprehensive testing and validation at each stage, followed by a gradual service rollout. Option B. Deploy the solution using only vendor-recommended default configurations to expedite the process and minimize customization efforts. Option C. Prioritize the immediate activation of all services upon initial hardware installation, deferring extensive testing to a later operational phase. Option D. Focus solely on minimizing initial deployment costs by selecting the most basic configuration and deferring capacity upgrades until service issues arise. The correct answer is A. Implement a phased deployment strategy with comprehensive testing and validation at each stage, followed by a gradual service rollout. Explanation. Scenario analysis. Deploying mobile backhaul solutions involves integrating new technologies with existing infrastructure, often under tight deadlines and budget constraints. A key challenge is ensuring that the chosen deployment strategy aligns with current and future service demands, regulatory compliance, and operational efficiency. The pressure to deliver services quickly can lead to shortcuts that compromise long-term stability and adherence to best practices. This scenario requires a balanced approach that prioritizes robust design and future-proofing over immediate, potentially superficial, gains. Correct approach analysis. The correct approach emphasizes a phased deployment strategy that includes thorough testing and validation at each stage. This aligns with best practices in network engineering and project management, ensuring that issues are identified and resolved early, minimizing disruption and risk. From a regulatory perspective, a well-documented and tested deployment reduces the likelihood of non-compliance with service-level agreements, SLAs, and operational standards. This methodical approach fosters a stable and reliable network, which is crucial for maintaining customer trust and meeting service obligations. It also allows for iterative feedback and adjustments, leading to a more optimized final solution. Incorrect approaches analysis. One incorrect approach involves prioritizing the immediate activation of services without adequate end-to-end testing. This poses a significant regulatory risk, as it could lead to service degradation, unmet SLAs, and potential penalties. Ethically, it demonstrates a disregard for customer experience and network integrity. Another incorrect approach is to solely rely on vendor default configurations. This is professionally unsound, as it fails to account for specific network requirements, security vulnerabilities, and potential interoperability issues, leading to suboptimal performance and increased risk of breaches. It also bypasses the due diligence expected in a professional deployment. A third incorrect approach, focusing exclusively on cost reduction by skipping crucial capacity planning, is also professionally negligent. It can lead to network congestion and performance issues down the line, impacting service quality and potentially violating regulatory requirements for service availability and performance. Professional reasoning. Professionals should adopt a decision-making framework that prioritizes a holistic view of the deployment. This involves understanding the technical requirements, operational constraints, regulatory obligations, and business objectives. A structured approach, incorporating risk assessment, phased implementation, rigorous testing, and continuous monitoring, is essential. When faced with pressure to expedite deployment, professionals must advocate for adherence to best practices, clearly articulating the risks associated with shortcuts and their potential impact on service quality, compliance, and long-term network health. Question 8. The review process indicates that a service provider is considering the integration of a new mobile backhaul technology that promises enhanced bandwidth and lower latency. However, the existing operational framework has strict change management protocols and requires thorough validation of any new solution before it impacts the live network. Which of the following approaches best aligns with professional best practices for deploying such a solution within this regulatory and operational context? Option A. Rely solely on the vendor's provided documentation and case studies to justify the deployment, without independent verification or testing. Option B. Immediately deploy the new technology in a limited live environment to gather real-world performance data and iterate based on observed results. Option C. Conduct a comprehensive proof of concept in a dedicated lab environment, simulating live network conditions, followed by a phased rollout based on successful validation. Option D. Prioritize the solution with the lowest upfront cost, assuming that any technical challenges can be addressed post-deployment through vendor support. The correct answer is B. Immediately deploy the new technology in a limited live environment to gather real-world performance data and iterate based on observed results. Explanation. The review process indicates a need to evaluate best practices in deploying Cisco service provider mobile backhaul solutions, specifically concerning the integration of new technologies while adhering to existing operational frameworks. The challenge lies in balancing innovation with the established requirements for network stability, security, and compliance, which are paramount in service provider environments. This scenario demands a thorough understanding of how new solutions impact the current operational landscape and how to mitigate potential risks. The correct approach represents best professional practice because it prioritizes a comprehensive, phased evaluation that includes rigorous testing in a controlled environment before full deployment. This aligns with industry best practices for network evolution, emphasizing risk mitigation and ensuring that new technologies do not negatively affect service availability or performance. It also implicitly considers the need for thorough documentation and training, which are critical for long-term operational success and compliance with any relevant service-level agreements or operational standards. An incorrect approach that bypasses thorough testing and validation in a lab environment before live deployment poses significant regulatory and ethical risks. It could lead to service disruptions, impacting customer experience and potentially violating service-level agreements, which can have financial and reputational consequences. Furthermore, deploying unproven technology without adequate risk assessment could violate network security policies and data privacy regulations if sensitive customer data is compromised. Another incorrect approach, focusing solely on cost reduction without considering the technical implications or long-term operational overhead, is professionally unsound. This can lead to the selection of solutions that are not robust, scalable, or secure, ultimately increasing operational costs through troubleshooting, maintenance, and potential failures. It also risks noncompliance with future regulatory mandates that may require specific performance or security standards. A third incorrect approach, prioritizing vendor recommendations without independent verification or consideration of the specific network environment, is also problematic. While vendor expertise is valuable, their recommendations may not always align with the unique constraints, existing infrastructure, or strategic goals of the service provider. This can lead to suboptimal solutions that are difficult to integrate, maintain, or scale, and may not meet the required performance or security benchmarks. The professional decision-making process for similar situations should involve a structured approach. First, clearly define the business and technical objectives for the new deployment. Second, conduct a thorough assessment of potential solutions, including their technical capabilities, security features, scalability, and compatibility with the existing infrastructure. Third, perform rigorous lab testing and proof-of-concept evaluations to validate performance and identify potential issues. Fourth, develop a detailed deployment plan that includes rollback strategies and contingency measures. Finally, ensure adequate training for operational staff and establish clear monitoring and support procedures. This systematic process ensures that decisions are data-driven, risk-aware, and aligned with both technical requirements and regulatory obligations. Question 9. The analysis reveals that a service provider is facing pressure to rapidly expand its mobile backhaul network to support new 5G services. Engineering teams are evaluating solutions, with some advocating for a single vendor's proprietary, highly integrated offering that promises quick deployment and simplified management, while others are pushing for a multi-vendor approach leveraging open standards to ensure long-term flexibility and avoid vendor lock-in. Considering the regulatory landscape that emphasizes service reliability and consumer protection, which approach best aligns with professional best practices for deploying a sustainable and adaptable mobile backhaul solution? Option A. Prioritize a phased deployment strategy that emphasizes interoperability and adherence to industry standards, allowing for gradual integration and future scalability. Option B. Select a single vendor's proprietary solution based on its perceived ease of integration and immediate cost benefits, accepting the potential for vendor lock-in. Option C. Defer comprehensive security implementation to a later phase, focusing solely on achieving the fastest possible network deployment timeline. Option D. Deploy the most advanced, cutting-edge technology available, assuming that future operational challenges can be addressed as they arise. The correct answer is A. Prioritize a phased deployment strategy that emphasizes interoperability and adherence to industry standards, allowing for gradual integration and future scalability. Explanation. Scenario analysis. This scenario presents a common challenge in mobile backhaul deployment, where a service provider must balance the immediate need for network expansion with the long-term implications of technology choices and vendor relationships. The pressure to meet aggressive deployment timelines, often driven by competitive market demands and subscriber growth, can lead to hasty decisions. Furthermore, the inherent complexity of backhaul technologies, including synchronization, transport, and security, requires a deep understanding of both current capabilities and future evolution. The stakeholder perspective is critical because different groups, engineering, finance, operations, marketing, will have varying priorities and risk tolerances, making consensus building difficult. Correct approach analysis. The correct approach emphasizes a phased deployment strategy that prioritizes interoperability and adherence to industry standards. This aligns with the principles of responsible network evolution and risk mitigation, which are implicitly encouraged by regulatory frameworks focused on service reliability and consumer protection. By selecting solutions that support open standards and offer clear upgrade paths, the service provider avoids vendor lock-in and ensures future flexibility. This proactive stance on interoperability and standardization is crucial for maintaining a robust and adaptable mobile backhaul network, which directly impacts the quality and availability of mobile services, a key concern for regulatory bodies overseeing telecommunications. This approach demonstrates foresight and a commitment to long-term network health, reflecting best professional practice in a regulated industry. Incorrect approaches analysis. One incorrect approach involves prioritizing a single vendor's proprietary solution solely based on perceived ease of integration and immediate cost savings. This creates a significant risk of vendor lock-in, limiting future options and potentially leading to higher long-term operational and upgrade costs. From a regulatory standpoint, this can be problematic if it hinders the provider's ability to adapt to new service requirements, or if the vendor's future product roadmap does not align with industry evolution, potentially impacting service quality or innovation. Another incorrect approach is to deploy the most advanced, cutting-edge technology without a clear understanding of its operational maturity or the availability of skilled personnel to manage it. While innovation is important, deploying unproven technologies can lead to instability, increased troubleshooting time, and service disruptions. This directly contravenes the implicit regulatory expectation of providing reliable and consistent service. It also fails to consider the practicalities of operational support and maintenance, which are essential for sustained service delivery. A third incorrect approach is to defer critical security considerations in favor of faster deployment. Security is a fundamental aspect of any network infrastructure, especially for mobile backhaul which carries sensitive subscriber data. Neglecting security from the outset introduces vulnerabilities that can lead to breaches, service disruptions, and regulatory penalties. Best professional practice dictates that security must be an integral part of the design and deployment process, not an afterthought. Professional reasoning. Professionals should adopt a decision-making framework that balances immediate operational needs with long-term strategic goals, regulatory compliance, and risk management. This involves thorough due diligence on technology options, prioritizing solutions that adhere to open standards and offer clear upgrade paths. Engaging all relevant stakeholders early in the process to understand their requirements and concerns is crucial for building consensus. A phased deployment approach, coupled with robust testing and validation, allows for the gradual introduction of new technologies and minimizes operational risk. Furthermore, a proactive security strategy, integrated from the design phase, is paramount to protecting network integrity and subscriber data. This systematic approach ensures that decisions are well-informed, technically sound, and ethically responsible, leading to a resilient and future-proof mobile backhaul network. Question 10. The monitoring system demonstrates intermittent packet loss on a key Ethernet backhaul link connecting a cell site to the aggregation network. The link is experiencing sporadic drops, impacting voice and data services. What is the most effective initial troubleshooting approach to identify the root cause? Option A. Verify physical layer integrity, including cable connections and transceiver status, and then examine interface statistics for errors and discards on both ends of the link. Option B. Focus exclusively on the Cisco iOS configuration of the routers, searching for potential routing or switching misconfigurations. Option C. Escalate the issue to the senior network engineering team for advanced diagnostics without performing initial link health checks. Option D. Immediately reconfigure quality of service (QoS) policies on the Cisco routers at both ends of the link to prioritize critical traffic. The correct answer is A. Verify physical layer integrity, including cable connections and transceiver status, and then examine interface statistics for errors and discards on both ends of the link. Explanation. The monitoring system demonstrates an intermittent packet loss issue affecting a critical mobile backhaul link. This scenario is professionally challenging because it directly impacts service availability for mobile subscribers, potentially leading to customer dissatisfaction and revenue loss. The pressure to restore service quickly can lead to hasty decisions. Furthermore, the intermittent nature of the problem makes it difficult to pinpoint the root cause, requiring a systematic and thorough investigation. The correct approach involves a methodical, layered troubleshooting methodology, starting with the physical layer and progressing upwards through the network stack. This aligns with best professional practices for network diagnostics and incident response, specifically verifying physical connectivity, checking link utilization, and examining interface statistics for errors are fundamental steps. This approach is also implicitly supported by general telecommunications best practices and service level agreements, SLAs, which mandate timely and effective fault resolution. While the exam focuses on Cisco solutions, the underlying principles of network troubleshooting are universally applicable and expected in professional practice. An incorrect approach would be to immediately assume a complex configuration issue or a hardware failure without first exhausting simpler, more probable causes. For instance, immediately reconfiguring CoS policies without verifying basic link health could lead to misdiagnosis and wasted effort. This is professionally unsound as it bypasses fundamental diagnostic steps. Another incorrect approach would be to escalate the issue to a higher support tier without performing adequate initial troubleshooting. This demonstrates a lack of ownership and can delay resolution, potentially violating internal procedures or customer commitments. A third incorrect approach would be to focus solely on the Cisco equipment involved, ignoring potential issues with upstream or downstream network segments or customer premises equipment. This narrow focus can lead to overlooking external factors contributing to the problem. Professionals should employ a structured troubleshooting framework, such as the OSI model or a similar layered approach, to systematically isolate the fault domain. This involves gathering information, forming hypotheses, testing hypotheses, and implementing solutions. When faced with intermittent issues, it is crucial to leverage monitoring tools effectively, correlate events, and document all troubleshooting steps and findings. This methodical process ensures that the most likely causes are investigated first, leading to efficient and effective problem resolution while adhering to professional standards of care and service delivery. Question 11. Market research demonstrates that a new vendor is aggressively promoting a proprietary mobile backhaul solution, claiming significant cost reductions and performance enhancements over existing technologies. The vendor's sales team is pressuring the service provider's engineering team to adopt this solution quickly, citing a limited time discount and the need to stay ahead of competitors. The proposed solution, however, has limited independent validation and deviates from established industry standards for interoperability. What is the most professional and ethically sound approach for the service provider's engineering team to take? Option A. Conduct a comprehensive, independent technical evaluation of the vendor's solution, including proof-of-concept testing and risk assessment, to determine its suitability and compliance with internal standards and industry best practices before considering any deployment. Option B. Immediately deploy the vendor's solution across a pilot segment of the network to capitalize on the limited time discount and gain early operational experience, relying on the vendor's assurances of performance. Option C. Reject the vendor's proposal outright due to its proprietary nature and deviation from industry standards, focusing only on solutions that are fully compliant with open standards. Option D. Prioritize the adoption of the new solution based on the vendor's claims of competitive advantage and cost savings, assuming that the limited time discount outweighs the need for extensive validation. The correct answer is A. Conduct a comprehensive, independent technical evaluation of the vendor's solution, including proof-of-concept testing and risk assessment, to determine its suitability and compliance with internal standards and industry best practices before considering any deployment. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in the conflict between a vendor's aggressive sales tactics and the service provider's responsibility to deploy solutions that are technically sound, cost-effective, and compliant with industry standards and regulations. The pressure to adopt a new, unproven technology based on vendor promises, without thorough independent validation, risks compromising network stability, security, and long-term operational efficiency. The ethical dilemma lies in balancing business objectives, potential cost savings, competitive advantage, with professional obligations to ensure the integrity and reliability of the mobile backhaul network. Correct approach analysis. The correct approach emphasizes a rigorous, evidence-based evaluation process. This involves independent technical validation of the vendor's proposed solution against established industry best practices and the service provider's specific requirements. It prioritizes due diligence, risk assessment, and a phased deployment strategy, ensuring that any new technology is thoroughly tested in a controlled environment before widespread adoption. This aligns with professional engineering ethics that mandate competence, integrity, and a commitment to public safety and welfare, which in the context of telecommunications includes network reliability and security. Adhering to Cisco's recommended deployment guidelines and relevant service provider standards, e.g., those pertaining to network resilience and interoperability, is paramount. Incorrect approaches analysis. One incorrect approach involves accepting the vendor's claims at face value and proceeding with immediate, large-scale deployment based solely on their assurances of cost savings and performance improvements. This fails to uphold the professional responsibility of independent verification and risk management. It could lead to significant network disruption, security vulnerabilities, and financial losses if the technology does not perform as advertised or introduces unforeseen issues. This approach also bypasses critical steps in the Cisco deployment framework, potentially violating internal governance and best practice guidelines. Another incorrect approach is to dismiss the vendor's proposal outright without any form of objective evaluation. While caution is warranted, a complete refusal to investigate a potentially beneficial technology, especially if it addresses a known operational challenge, could be seen as a failure to act in the best interest of the service provider. It might stem from a lack of open-mindedness or an unwillingness to engage in the necessary due diligence, potentially missing an opportunity for innovation or efficiency gains. This could also be viewed as a failure to stay abreast of technological advancements relevant to the field. A third incorrect approach is to prioritize the vendor's proposed solution solely because it is a new offering, without a clear understanding of its technical merits or its alignment with the service provider's strategic goals. This shiny object syndrome can lead to the adoption of immature or unsuitable technologies, creating more problems than it solves. It neglects the fundamental engineering principle of selecting solutions based on proven performance, reliability, and suitability for the specific operational environment, rather than on novelty alone. Professional reasoning. Professionals in this field should adopt a structured decision-making process that begins with clearly defining the problem or opportunity. This involves understanding the service provider's current network architecture, operational challenges, and strategic objectives. Next, potential solutions, including vendor proposals, should be identified. Crucially, each proposed solution must undergo a thorough technical evaluation, including proof-of-concept testing, interoperability checks, and security assessments, against predefined criteria. Risk assessment and mitigation planning are essential throughout this process. Finally, a phased deployment strategy with clear rollback plans should be implemented for any chosen solution, ensuring continuous monitoring and performance validation. This systematic approach, grounded in technical expertise and ethical responsibility, ensures that decisions are informed, justifiable, and ultimately serve the best interests of the service provider and its customers. Question 12. During the evaluation of a new Cisco mobile backhaul solution intended to increase capacity and support emerging 5G services, what is the most critical aspect of the impact assessment to ensure compliance with service-level agreements and maintain network integrity? Option A. A plan to deploy the solution in a limited segment of the network and address any identified issues after the initial rollout. Option B. A comprehensive assessment of the solution's integration with existing network elements, its performance under simulated peak traffic loads, and its security posture against potential threats. Option C. A preliminary review of the solution's basic technical specifications to confirm it meets the minimum advertised capacity requirements. Option D. A detailed analysis of the vendor's pricing structure and the potential for immediate cost reductions compared to the current backhaul infrastructure. Correct answer is B. A comprehensive assessment of the solution's integration with existing network elements, its performance under simulated peak traffic loads, and its security posture against potential threats. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent complexity of mobile backhaul solutions and the critical need to assess their impact on existing network services and future scalability. Service providers operate under strict service-level agreements, SLAs, and regulatory compliance mandates, making any deployment or modification a high-stakes undertaking. The challenge lies in anticipating potential disruptions, ensuring seamless integration, and verifying that the new solution not only meets current demands, but also supports anticipated growth in mobile data traffic and new service offerings, all while adhering to relevant industry standards and regulations. Correct approach analysis. The correct approach involves a comprehensive, multifaceted impact assessment that considers technical performance, service continuity, security implications, and operational readiness. This includes rigorous testing in a lab environment that mirrors production conditions, detailed analysis of traffic patterns and capacity requirements, and a thorough review of security vulnerabilities. Furthermore, it necessitates engagement with all relevant stakeholders, including network operations, engineering, and potentially regulatory compliance teams, to ensure all aspects are covered. This holistic approach aligns with best professional practices by proactively identifying and mitigating risks, ensuring compliance with SLAs and regulatory requirements, and ultimately safeguarding the integrity and performance of the mobile backhaul network. Incorrect approach is analysis, focusing solely on the technical specifications of the new equipment without considering its integration into the existing network, and its impact on end-user services represents a significant regulatory and ethical failure. This narrow view risks overlooking potential bottlenecks, performance degradation, or service interruptions, which could lead to SLA breaches and customer dissatisfaction. It also fails to address potential security vulnerabilities introduced by new hardware or configurations, which is a critical compliance concern. Prioritizing cost savings above all else, without a thorough impact assessment, is another regulatory and ethical pitfall. While cost-effectiveness is important, it cannot come at the expense of network reliability, performance, or security. Such an approach could lead to the deployment of solutions that are inadequate for current or future demands, ultimately costing more in the long run due to troubleshooting, service restoration, and potential regulatory fines. Adopting a deploy and fix later mentality, where the impact assessment is minimal and issues are addressed reactively, is professionally unacceptable and carries severe regulatory and ethical implications. This approach demonstrates a disregard for customer experience, SLA commitments, and network stability. It can lead to widespread service outages, significant financial penalties, and reputational damage, all of which are direct violations of professional responsibility and potentially regulatory mandates concerning service availability. Professional reasoning. Professionals should adopt a risk-based approach to impact assessment. This involves identifying potential risks associated with the new solution, evaluating their likelihood and severity, and developing mitigation strategies. A structured methodology, including detailed planning, testing, validation, and stakeholder communication, is essential. Professionals must always prioritize network stability, service quality, security, and regulatory compliance. Decision-making should be guided by a thorough understanding of the business objectives, technical requirements, and the potential consequences of any deployment. Question 13. The evaluation methodology shows a critical need to assess the potential impact of introducing a new MPLS-based mobile backhaul solution on existing network stability and customer service continuity. Which risk assessment approach best aligns with the regulatory framework for service providers focused on ensuring reliable service delivery and minimizing operational disruptions? Option A. Conduct a comprehensive risk assessment that quantifies potential failure points, analyzes their impact on service availability and performance metrics, and develops specific mitigation plans for high-priority risks, ensuring alignment with service-level agreements and regulatory compliance mandates. Option B. Rely on the vendor's assurance of the technology's stability without conducting an independent, in-depth risk assessment of its integration into the existing service provider network. Option C. Focus primarily on identifying the lowest cost implementation options for the MPLS-TE backhaul, deferring detailed risk analysis until after the initial deployment phase. Option D. Prioritize the technical performance benchmarks of the new MPLS-TE solution, assuming that superior technical capabilities will inherently mitigate operational risks. The correct answer is A. Conduct a comprehensive risk assessment that quantifies potential failure points, analyzes their impact on service availability and performance metrics, and develops specific mitigation plans for high-priority risks, ensuring alignment with service-level agreements and regulatory compliance mandates. Explanation. The evaluation methodology shows a critical juncture in deploying a new mobile backhaul solution, specifically concerning the risk assessment phase. The professional challenge lies in balancing the imperative to innovate and deploy new technologies with the inherent risks associated with network changes, especially in a service provider context where service availability and customer experience are paramount. A robust risk assessment must proactively identify potential threats, vulnerabilities, and their impact, allowing for mitigation strategies to be implemented before deployment. This requires a deep understanding of the technology, the operational environment, and the regulatory landscape governing service provision. The correct approach represents best professional practice because it systematically identifies and quantifies potential risks, aligning them with business objectives and regulatory compliance. By prioritizing risks based on their likelihood and impact, resources can be allocated effectively to address the most critical issues first. This proactive stance minimizes the probability of service disruption, security breaches, or noncompliance, which are all significant concerns for service providers. Adhering to established risk management frameworks, such as those implicitly or explicitly referenced in Cisco's best practices for service provider solutions, ensures a structured and defensible process. This aligns with the overarching goal of ensuring reliable and secure network operation, a fundamental requirement for any service provider. An incorrect approach that focuses solely on the technical feasibility of the new backhaul technology, without a comprehensive risk assessment, fails to acknowledge the operational and business implications. This is a regulatory failure because it neglects the responsibility to ensure service continuity and customer satisfaction, which are often stipulated in service-level agreements, SLAs, and regulatory mandates for telecommunications providers. Ethically, it demonstrates a lack of due diligence in protecting the network and its users from potential harm. Another incorrect approach that prioritizes cost reduction above all else, even when significant risks are identified, is also professionally unacceptable. This represents a regulatory failure by potentially compromising network integrity and security to meet financial targets, which can lead to violations of service quality regulations. Ethically, it prioritizes short-term financial gains over long-term network stability and customer trust. A third incorrect approach that relies on anecdotal evidence or past experiences with similar, but not identical, technologies without a formal documented risk assessment is insufficient. This is a procedural and ethical failure. It lacks the rigor required for a formal risk assessment, making it difficult to justify decisions or demonstrate compliance. It also fails to account for the unique characteristics of the new deployment, potentially leading to unforeseen issues. The professional decision-making process for similar situations should involve a structured risk management framework. This begins with identifying all potential risks across technical, operational, security, and business domains. Each identified risk should then be analyzed for its likelihood of occurrence and potential impact. Based on this analysis, risks are prioritized, and appropriate mitigation, avoidance, transference, or acceptance strategies are developed. These strategies must be documented, implemented, and continuously monitored. Crucially, the entire process must be aligned with relevant industry standards and regulatory requirements to ensure both operational excellence and legal compliance. Question 14. Benchmark analysis indicates that a service provider is experiencing significant pressure to accelerate the deployment of a new mobile backhaul solution to meet competitive market demands. The project team is considering several approaches to manage the associated risks. Which approach best aligns with professional best practices and regulatory expectations for deploying such solutions? Option A. Conduct a comprehensive risk assessment that identifies, analyzes, and documents mitigation strategies for potential network performance, security, and operational risks throughout the design and implementation phases, integrating these findings into the deployment plan. Option B. Perform a cursory risk assessment focusing only on the most apparent and easily measurable risks, assuming that more complex or subtle risks are unlikely to materialize. Option C. Rely exclusively on the risk assessment provided by the equipment vendor, without conducting an independent evaluation tailored to the service provider's specific network environment and policies. Option D. Defer the detailed risk assessment until after the mobile backhaul solution has been fully deployed and is operational, to avoid delaying the initial service activation. The correct answer is A. Conduct a comprehensive risk assessment that identifies, analyzes, and documents mitigation strategies for potential network performance, security, and operational risks throughout the design and implementation phases, integrating these findings into the deployment plan. Explanation. Scenario analysis. The scenario presents a common challenge in deploying new mobile backhaul solutions, balancing the need for rapid deployment and service activation with the imperative to conduct thorough risk assessments. Service providers operate in a highly competitive market where time to market is critical. However, neglecting risk assessment can lead to significant operational disruptions, security vulnerabilities, and noncompliance with regulatory mandates, all of which can have severe financial and reputational consequences. The pressure to meet aggressive deployment timelines, coupled with the complexity of modern backhaul technologies and their integration into existing networks, makes a structured and comprehensive risk assessment process essential, even under time constraints. Correct approach analysis. The correct approach involves integrating risk assessment activities into the project lifecycle from the outset, rather than treating it as a separate, post-deployment checklist. This means identifying potential risks related to network performance, security, scalability, and operational manageability during the design and planning phases. For each identified risk, mitigation strategies should be developed and documented. This proactive stance ensures that potential issues are addressed before they impact service delivery or violate regulatory requirements. In the context of Cisco service provider mobile backhaul solutions, this would involve assessing risks associated with specific technologies like MPLS, segment routing, or synchronization methods, and ensuring they align with the service provider's security policies and any relevant telecommunications regulations. This approach represents best professional practice because it minimizes the likelihood of costly rework, service outages, and regulatory penalties, thereby safeguarding the provider's reputation and financial stability. Incorrect approaches analysis. One incorrect approach is to defer the comprehensive risk assessment until after the solution has been fully deployed and is operational. This is a reactive strategy that fails to identify and mitigate risks during the critical design and implementation phases. Such a delay significantly increases the probability of encountering unforeseen problems, leading to service disruptions, security breaches, or performance degradation. From a regulatory perspective, this approach could violate mandates requiring risk management and security by design, potentially leading to fines or sanctions. Another incorrect approach is to conduct a superficial risk assessment that focuses only on the most obvious or easily quantifiable risks, while ignoring more subtle or complex threats. This might involve overlooking risks related to interoperability with legacy systems, the impact of new traffic patterns on network stability, or the potential for unauthorized access to sensitive network elements. This shallow analysis fails to provide a true picture of the potential vulnerabilities and can leave the network exposed to significant threats, which is a failure in due diligence and professional responsibility. A third incorrect approach is to rely solely on vendor-provided risk assessments without conducting an independent evaluation. While vendor assessments can be valuable, they may not fully account for the specific operational environment, existing infrastructure, or unique security policies of the service provider. This can lead to a blind spot in the risk assessment process, potentially missing critical risks that are specific to the provider's deployment. This abdication of responsibility for risk assessment is professionally unsound and could lead to non-compliance with regulatory obligations. Professional reasoning. Professionals should adopt a risk-based approach that is embedded within the project management framework. This involves establishing clear risk identification, analysis, and mitigation processes. When faced with time pressures, the decision-making process should prioritize risks based on their potential impact and likelihood. High impact, high likelihood risks must be addressed proactively, even if it requires adjusting timelines or scope. The professional should always consider the regulatory landscape, ensuring that all deployed solutions comply with relevant telecommunications laws and security standards. A continuous risk monitoring and review process should be established to adapt to evolving threats and network changes. Question 15. Regulatory review indicates that new service provider mobile backhaul solutions must adhere to stringent uptime and resilience mandates to ensure continuity of critical communication services. When evaluating a proposed Cisco mobile backhaul solution that leverages advanced packet-based transport, which approach best aligns with these regulatory requirements and professional best practices for deployment? Option A. Focus primarily on achieving the lowest possible operational expenditure for the new backhaul solution, deferring any detailed regulatory compliance checks until after the network has been fully implemented and is operational. Option B. Prioritize a comprehensive technical validation of the solution's performance metrics against the specific uptime and resilience clauses outlined in the relevant telecommunications regulatory framework, engaging with regulatory bodies for clarification on any ambiguities before final deployment. Option C. Proceed with deployment based on the assumption that the solution's inherent technical capabilities, as described by the vendor, will automatically satisfy all regulatory uptime and resilience requirements without explicit verification against the specific legal mandates. Option D. Conduct a high-level review of general industry best practices for network resilience, assuming these will be sufficient to meet the specific, legally binding uptime and resilience requirements stipulated by the governing regulatory body. The correct answer is B. Prioritize a comprehensive technical validation of the solution's performance metrics against the specific uptime and resilience clauses outlined in the relevant telecommunications regulatory framework, engaging with regulatory bodies for clarification on any ambiguities before final deployment. Explanation. This scenario presents a common challenge in deploying new mobile backhaul solutions, ensuring compliance with evolving regulatory requirements for network resilience and service continuity, particularly in the context of critical infrastructure. The professional challenge lies in balancing the technical advantages of a proposed solution with the legal and operational mandates set forth by regulatory bodies. A deep understanding of the specific regulations governing telecommunications infrastructure in the relevant jurisdiction is paramount. The correct approach represents best professional practice because it prioritizes a thorough, proactive assessment against established regulatory frameworks. This involves engaging with regulatory bodies early, conducting detailed impact analyses, and ensuring that the proposed solution demonstrably meets or exceeds mandated resilience and availability standards. This proactive stance mitigates risks of noncompliance, potential service disruption, and subsequent penalties. It aligns with the ethical obligation to provide reliable and secure services that are essential for public safety and economic activity, as often stipulated in telecommunications law. An incorrect approach that focuses solely on cost reduction without a commensurate evaluation of regulatory compliance would be professionally unacceptable. This failure stems from a disregard for legal obligations, potentially leading to significant fines, reputational damage, and the need for costly remediation. Another incorrect approach, which assumes existing compliance without verification, ignores the dynamic nature of regulations and the specific requirements of new technologies. This oversight can result in deploying a network that, while technically sound, fails to meet current legal standards, thereby exposing the service provider to regulatory action. A third incorrect approach, which delays engagement with regulatory bodies until after deployment, demonstrates poor risk management and a lack of foresight. This can lead to mandatory, disruptive changes to the network, impacting service delivery and customer trust. The professional decision-making process for similar situations should involve a structured risk assessment framework. This framework should include 1. Identifying all applicable regulatory requirements relevant to the technology and service being deployed. 2. Conducting a gap analysis between the proposed solution's capabilities and these requirements. 3. Engaging in early and continuous dialogue with regulatory authorities. 4. Documenting all compliance efforts and justifications. 5. Establishing internal processes for ongoing monitoring and adaptation to regulatory changes. This systematic approach ensures that technical innovation is pursued responsibly and within the bounds of legal and ethical obligations. Question 16. The audit findings indicate that the current mobile backhaul infrastructure is increasingly reliant on hardware and software nearing end of life, posing a significant risk to service availability and potentially impacting compliance with future performance mandates. Considering the need to upgrade to support growing 5G traffic demands and reduce latency, which of the following approaches best represents a professional and compliant strategy for modernizing the backhaul solution? Option A. Undertake a series of ad hoc, uncoordinated upgrades of individual components as they fail or become prohibitively expensive to maintain, without a comprehensive integration plan. Option B. Immediately replace all existing backhaul infrastructure with the latest available technology across the entire network simultaneously to ensure maximum future-proofing. Option C. Implement a phased migration strategy, prioritizing critical services and leveraging newer technologies that offer improved performance, security, and scalability, while ensuring thorough testing and interoperability. Option D. Defer all upgrade activities indefinitely until a significant service outage occurs, at which point a reactive, emergency replacement of all components will be initiated. The correct answer is C. Implement a phased migration strategy, prioritizing critical services and leveraging newer technologies that offer improved performance, security, and scalability, while ensuring thorough testing and interoperability. Explanation: scenario analysis. This scenario presents a common challenge in service provider environments where network upgrades are necessary to meet evolving mobile backhaul demands, such as increased bandwidth for 5G services and lower latency requirements. The challenge lies in balancing the immediate need for operational continuity and service availability with the long-term strategic goals of network modernization and compliance with evolving industry standards and potential regulatory mandates for network performance and security. The audit findings highlight a potential gap in proactive planning and risk assessment related to technology obsolescence, which can lead to service degradation and security vulnerabilities if not addressed. Correct approach analysis. The correct approach involves a phased migration strategy that prioritizes critical services and leverages newer technologies that offer improved performance, security, and scalability. This aligns with best practices for network evolution, ensuring that essential mobile backhaul functions remain operational while gradually introducing more advanced solutions. This approach minimizes disruption to existing services, allows for thorough testing of new components, and facilitates a controlled transition. It also demonstrates due diligence in addressing potential risks identified by the audit, such as the deprecation of older hardware and software, thereby maintaining compliance with general principles of network reliability and service assurance expected by regulatory bodies overseeing telecommunications infrastructure. A focus on interoperability and adherence to industry standards ensures that the network remains robust and capable of supporting future services. Incorrect approaches analysis. One incorrect approach involves delaying the upgrade indefinitely due to cost concerns. This is professionally unacceptable as it directly contradicts the audit findings and ignores the increasing risk of service disruption and security breaches associated with outdated equipment. It also fails to meet the implicit expectation of maintaining a modern and reliable network infrastructure, which could have regulatory implications if service levels are not maintained. Another incorrect approach is to immediately replace all existing infrastructure with the latest technology without a phased plan. While seemingly decisive, this approach carries a high risk of operational disruption, potential interoperability issues, and significant unforeseen costs. It bypasses the crucial step of risk mitigation and controlled implementation, which is a cornerstone of professional network deployment and management. This could lead to non-compliance with service-level agreements and potentially violate regulations concerning network stability and service continuity. A third incorrect approach is to implement a piecemeal upgrade strategy without a clear roadmap or integration plan. This can lead to a fragmented network architecture, increased complexity in management and troubleshooting, and potential security vulnerabilities due to inconsistent security policies across different network segments. It fails to address the holistic needs of the mobile backhaul solution and may not achieve the desired performance or scalability improvements, thus not meeting the spirit of the audit's recommendations for modernization. Professional reasoning. Professionals should approach network modernization by first thoroughly understanding the audit findings and their implications for service continuity, performance, and security. This involves assessing the risks associated with the current infrastructure, particularly concerning end-of-life hardware and software. A best practice is to develop a comprehensive migration plan that includes a phased rollout, rigorous testing, and clear rollback procedures. This plan should prioritize critical services and gradually introduce new technologies, ensuring interoperability and adherence to industry standards. Continuous monitoring and evaluation throughout the migration process are essential to identify and address any emerging issues promptly. This systematic and risk-aware approach ensures that the network evolves effectively while maintaining service integrity and meeting regulatory expectations for reliable telecommunications services. Question 17. Compliance review shows that a service provider is deploying a new Cisco mobile backhaul solution. The deployment team is prioritizing speed to market and has proposed implementing security features and compliance checks only after the core network infrastructure is fully operational. What is the most appropriate approach to ensure regulatory adherence and robust security? Option A. Integrate security and compliance requirements into the solution design and architecture from the initial stages, ensuring ongoing monitoring and auditing post-deployment. Option B. Rely on vendor default security configurations and assume they meet all regulatory requirements without further validation. Option C. Defer the comprehensive review of compliance implications until a security incident occurs to focus resources on immediate deployment needs. Option D. Implement security features and compliance checks after the core network infrastructure is fully operational to avoid delaying the deployment timeline. The correct answer is A. Integrate security and compliance requirements into the solution design and architecture from the initial stages, ensuring ongoing monitoring and auditing post-deployment. Explanation. Scenario analysis. This scenario presents a professional challenge because it requires balancing the technical imperative of deploying a new mobile backhaul solution with the stringent regulatory requirements governing network security and data privacy. The challenge lies in ensuring that the chosen implementation strategy, while efficient and effective from a technical standpoint, does not inadvertently create vulnerabilities or violate compliance mandates. The pressure to meet deployment timelines can sometimes lead to shortcuts that compromise security, making a thorough understanding of regulatory frameworks essential. Correct approach analysis. The correct approach involves a proactive and integrated strategy that embeds security and compliance considerations from the initial design phase through to deployment and ongoing operation. This aligns with the principles of security by design and privacy by design, which are increasingly mandated by regulatory bodies. Specifically, for mobile backhaul solutions, this means ensuring that encryption protocols are robust, access controls are granular and auditable, and that the network architecture itself minimizes potential attack vectors. Adherence to relevant Cisco documentation and best practices for service providers, which are implicitly aligned with industry standards and regulatory expectations, is crucial. This approach ensures that the solution is not only technically sound, but also legally defensible and ethically responsible, safeguarding customer data and network integrity. Incorrect approach is analysis. Implementing security measures only after the network is operational represents a significant regulatory and ethical failure. This reactive approach often leads to costly remediation, potential data breaches, and non-compliance penalties. It violates the principle of proactive risk management, which is a cornerstone of most data protection regulations. Deploying the solution without a comprehensive review of potential compliance implications, relying solely on vendor default configurations, is also a failure. This demonstrates a lack of due diligence and an abdication of responsibility to understand and adhere to the specific regulatory landscape governing the service provider's operations. Default configurations may not meet the required security standards or may contain known vulnerabilities. Ignoring the need for ongoing monitoring and auditing of security controls post-deployment is another critical failure. Compliance is not a one-time event. It requires continuous vigilance. Failure to monitor can lead to undetected security breaches or policy violations, which can have severe legal and reputational consequences. Professional reasoning. Professionals must adopt a risk-based approach, prioritizing compliance and security throughout the entire project lifecycle. This involves 1. Thoroughly understanding the applicable regulatory framework relevant to mobile backhaul operations in the specific jurisdiction. 2. Integrating security and compliance requirements into the solution design and architecture from the outset. 3. Conducting rigorous testing and validation to ensure that security controls are effective and meet regulatory standards. 4. Establishing robust operational procedures for ongoing monitoring, auditing, and incident response. 5. Maintaining detailed documentation of all security and compliance-related decisions and actions for audit purposes. Question 18. Implementation of a new enterprise data service on a shared Cisco service provider mobile backhaul network requires careful consideration of existing traffic. What is the most professional approach to ensure the mobile backhaul service's stringent latency and jitter requirements are maintained while integrating the new service? Option A. Over-provision the total bandwidth of the network links to accommodate the new service, without specific co-S configuration for different traffic types. Option B. Deploy the new enterprise data service with default co-S settings, assuming the existing network capacity is sufficient to handle the additional load without impacting mobile backhaul performance. Option C. Temporarily disable Co-S on the mobile backhaul interfaces to simplify the integration of the new enterprise data service, planning to re-enable it after the new service is stable. Option D. Implement granular quality of service (CO-S) policies on the Cisco devices to prioritize mobile backhaul traffic, ensuring it receives preferential treatment for bandwidth, latency, and jitter, before allowing the new enterprise data service to utilize remaining resources. The correct answer is D. Implement granular quality of service (CO-S) policies on the Cisco devices to prioritize mobile backhaul traffic, ensuring it receives preferential treatment for bandwidth, latency, and jitter, before allowing the new enterprise data service to utilize remaining resources. Explanation: the scenario presents a common implementation challenge in mobile backhaul, ensuring quality of service (CO-S) for critical mobile traffic while integrating new services onto an existing infrastructure. The challenge lies in balancing the performance requirements of different traffic types, particularly the stringent latency and jitter demands of mobile backhaul, with the need for efficient resource utilization and adherence to service-level agreements, SLAs. Professionals must navigate technical complexities, potential service disruptions, and the implicit or explicit regulatory expectations for reliable telecommunications services. Correct approach involves a phased deployment strategy that prioritizes the mobile backhaul traffic. This means meticulously planning the configuration of CO-S policies, traffic shaping, and queuing mechanisms on the Cisco routers, and switches to guarantee that mobile backhaul packets receive preferential treatment. This aligns with the regulatory expectation of maintaining a high standard of service for essential telecommunications, which often includes mobile services. By isolating and prioritizing mobile backhaul, operators demonstrate due diligence in safeguarding critical infrastructure, thereby minimizing the risk of regulatory noncompliance related to service availability and performance. This proactive approach ensures that the core function of the backhaul is not compromised by the introduction of new, potentially less critical, services. An incorrect approach would be to implement new services without a thorough CO-S assessment and prioritization of existing mobile backhaul traffic. This could lead to congestion, increased latency, and jitter, directly impacting the performance of mobile services. From a regulatory perspective, this failure to maintain service quality could result in breaches of SLAs and potential penalties, as telecommunications providers are generally held to a standard of providing reliable and performant services. Ethically, it represents a failure to uphold the commitment to existing customers and critical infrastructure. Another incorrect approach would be to over-provision bandwidth indiscriminately for all services without granular CO-S control. While seemingly a solution to congestion, this is often economically inefficient and does not guarantee the specific performance characteristics required by mobile backhaul. It fails to address the nuanced requirements of low latency and jitter, potentially leading to suboptimal performance for critical traffic. This approach also risks violating regulatory principles that encourage efficient use of network resources and may not meet specific performance metrics mandated for mobile backhaul. Finally, a flawed approach would be to assume that standard Ethernet CO-S settings are sufficient for mobile backhaul without specific tuning. Mobile backhaul has unique traffic patterns and stringent requirements that often necessitate specialized CO-S configurations beyond default settings. Relying on generic configurations ignores the specific technical demands and potential regulatory implications of failing to meet the performance benchmarks for this critical service. This oversight can lead to service degradation and non-compliance with industry best practices and regulatory mandates for mobile network performance. Question 19. System analysis indicates a proposed upgrade to the mobile backhaul network infrastructure, involving the introduction of new Cisco routers to support increased capacity for 5G services. The deployment team is under pressure to activate these new services rapidly to meet market demand and contractual obligations. What is the most appropriate approach to ensure network stability and compliance while facilitating timely service deployment? Option A. Implement the change immediately to meet service activation deadlines, deferring any formal impact assessment until after the services are live and stable. Option B. Rely on the informal knowledge and experience of senior network engineers to guide the deployment, without formal documentation or assessment. Option C. Proceed with the deployment based on the vendor's assurance of compatibility and performance, assuming minimal disruption to existing services. Option D. Conduct a comprehensive impact assessment that evaluates the effects on existing services, network performance, security, and operational manageability, and consult relevant internal documentation and regulatory guidelines. Correct answer is D. Conduct a comprehensive impact assessment that evaluates the effects on existing services, network performance, security, and operational manageability, and consult relevant internal documentation and regulatory guidelines. Explanation. Scenario analysis. This scenario presents a common challenge in mobile backhaul deployment, balancing the need for rapid service activation with the imperative to adhere to established network change management and impact assessment procedures. The pressure to meet service level agreements, SLAs, for new mobile services can lead to shortcuts, potentially jeopardizing network stability and compliance. The professional challenge lies in navigating these competing demands, ensuring that all necessary evaluations are performed without unduly delaying critical service deployments. This requires a thorough understanding of the potential ripple effects of network changes across various service layers and operational domains. Correct approach analysis. The correct approach involves a structured and comprehensive impact assessment that considers all relevant aspects of the proposed backhaul modification. This includes evaluating the potential effects on existing mobile services, e.g., voice, data, signaling, network performance metrics, latency, jitter, throughput, security posture, and operational manageability. It also necessitates consulting relevant documentation, such as network design guides, operational procedures, and any applicable regulatory compliance requirements related to service availability and data integrity. This systematic evaluation ensures that potential risks are identified and mitigated before implementation, aligning with best practices for network engineering and service provider operations. Adherence to such a process is crucial for maintaining network reliability and meeting customer expectations, which are often implicitly or explicitly governed by service provider regulations and industry standards. Incorrect approaches analysis. Implementing the change without a formal impact assessment is a significant regulatory and ethical failure. It bypasses critical risk management processes designed to prevent service disruption and potential breaches of SLAs. This approach disregards the principle of due diligence, which is fundamental in regulated industries like telecommunications, where service continuity is paramount. Proceeding with the change based solely on the vendor's assurance of compatibility, without independent verification or internal assessment, is also professionally unacceptable. While vendor information is valuable, it does not absolve the service provider of their responsibility to ensure the change meets their specific network conditions and operational requirements. This can lead to unforeseen interoperability issues or performance degradations that violate regulatory obligations for service quality. Relying on tribal knowledge or informal discussions among engineers, while sometimes efficient, lacks the rigor and documentation required for proper impact assessment. This approach is prone to errors, omissions, and a lack of accountability, making it difficult to trace the decision-making process and identify root causes in case of future issues. It fails to meet the standards of auditable and repeatable processes expected in a regulated environment. Professional reasoning. Professionals should adopt a proactive and systematic approach to network changes. This involves establishing and consistently following a robust change management process that mandates a thorough impact assessment for all modifications. Key steps include identifying the scope of the change, analyzing potential impacts across all affected network elements and services, consulting relevant documentation and stakeholders, developing a rollback plan, and obtaining necessary approvals. This structured methodology ensures that risks are managed effectively, compliance is maintained, and service quality is preserved, reflecting a commitment to professional responsibility and operational excellence. Question 20. Benchmark analysis indicates that a service provider is planning a rapid expansion of its 5G mobile backhaul network across several metropolitan areas. The regulatory framework in the primary operating jurisdiction mandates that lawful intercept capabilities must be fully functional and compliant from the moment any new service is activated. The technical team is evaluating different deployment strategies for the Cisco-based backhaul infrastructure, with a strong emphasis on speed and cost efficiency. which approach best ensures adherence to the lawful intercept mandates while enabling the planned service expansion. Option A. Implement standard network monitoring and logging tools, assuming these will provide sufficient data for any potential lawful intercept requests, and deferring specialized LI hardware or software until a specific need arises. Option B. Prioritize the deployment of end-to-end encryption for all backhaul traffic to enhance security and privacy, with the understanding that lawful intercept can be addressed through a separate, post-deployment solution if required. Option C. Focus on deploying the core backhaul infrastructure with maximum bandwidth and minimal latency, deferring any lawful intercept considerations to a later phase once the network is stable and operational. Option D. Design the backhaul network with integrated lawful intercept points and mirroring capabilities within the Cisco routing and switching fabric, ensuring traffic can be accessed and delivered according to regulatory specifications from day one of service activation. The correct answer is D. Design the backhaul network with integrated lawful intercept points and mirroring capabilities within the Cisco routing and switching fabric, ensuring traffic can be accessed and delivered according to regulatory specifications from day one of service activation. Explanation. Scenario analysis. This scenario presents a common challenge in mobile backhaul deployment where network operators must balance the need for rapid service expansion with the stringent requirements of regulatory compliance, specifically concerning lawful intercept capabilities. The pressure to deploy new services quickly can lead to shortcuts or overlooking critical regulatory mandates. The professional challenge lies in ensuring that all technical decisions, even those seemingly minor, align with legal obligations and do not inadvertently create vulnerabilities or non-compliance. The complexity arises from the need to integrate these capabilities seamlessly into a modern, high-speed backhaul architecture without compromising performance or security. Correct approach analysis. The correct approach involves proactively integrating lawful intercept, LI, capabilities into the network design from the outset, ensuring that all traffic flows are identifiable and accessible according to regulatory specifications. This aligns with the principles of privacy by design and security by design, which are increasingly embedded in regulatory frameworks for telecommunications. By incorporating LI features into the core backhaul architecture, such as through dedicated network taps or by ensuring specific traffic mirroring capabilities within the Cisco routers and switches, the operator fulfills its legal obligations without compromising the integrity or efficiency of the backhaul. This proactive stance minimizes the risk of future costly remediation and ensures continuous compliance, which is paramount in regulated industries. The focus is on building compliance into the infrastructure rather than attempting to retrofit it later. Incorrect approaches analysis. One incorrect approach is to defer the implementation of lawful intercept capabilities to a later stage, assuming that existing network traffic can be retrospectively captured or that a separate overlay network can be used. This is professionally unacceptable because it directly violates regulatory timelines and requirements for immediate lawful intercept access. Many jurisdictions mandate that LI capabilities must be operational from the moment a service is deployed. Furthermore, attempting to retrofit LI into an existing, non-compliant architecture is often technically complex, expensive, and prone to errors, potentially leading to data loss or incomplete intercepts, thus failing regulatory audits. Another incorrect approach is to rely solely on end-to-end encryption for all traffic, arguing that it enhances security and privacy. While encryption is a vital security measure, it can be a regulatory failure if it prevents lawful intercept mechanisms from accessing the necessary data. Regulations typically require that authorized entities can access traffic for lawful purposes, and if the encryption keys are not managed in a way that allows for lawful access, or if the encryption itself is not designed to be bypassed for LI purposes, it creates a direct conflict with legal mandates. This approach prioritizes a single aspect of security over a legally mandated requirement, demonstrating a lack of comprehensive understanding of the regulatory landscape. A third incorrect approach is to assume that standard network monitoring tools are sufficient for lawful intercept. While these tools can provide valuable insights, they are generally not designed to meet the specific, stringent requirements of lawful intercept, which often involve dedicated hardware or software, precise data formatting, and secure delivery mechanisms mandated by law enforcement agencies. Relying on general monitoring can lead to incomplete, unformatted, or insecure data, failing to meet the legal standards for evidence collection, and thus constituting a regulatory failure. Professional reasoning. Professionals in this field must adopt a decision-making framework that prioritizes regulatory compliance as a foundational element of network design and deployment. This involves 1. Thoroughly understanding all applicable regulatory requirements for lawful intercept in the relevant jurisdiction. 2. Integrating these requirements into the initial network architecture and design phases, treating them as non-negotiable functional requirements. 3. Collaborating with legal and compliance teams to ensure technical solutions meet legal standards. 4. Conducting rigorous testing and validation of lawful intercept capabilities throughout the deployment lifecycle. 5. Maintaining ongoing awareness of evolving regulatory landscapes and updating network designs accordingly. This proactive, compliance-first approach ensures that technical solutions not only meet performance and operational goals, but also uphold legal and ethical obligations.